Now, the thing is, this is when we start making surfactant, right? My goal, if you learn one thing when we finish this, you're going to understand surfactant, right? Because it's a big deal, because you really can determine whether the fetus is viable based on whether they're able to make surfactant. So usually that 20-week mark is like the mark. You don't want to go any further, any less than that. Ideally, you can get, if the child is premature, you want to get to the 26th week, all right? Because at the 20th week, you start making surfactant. Now, there are medications, which we'll talk about in a little bit, where you can increase surfactant production by giving it to the mother, like glucocorticoids. But that 20th week is when the child will start making surfactant. So if you have a child before that, you're worried about respiratory distress syndrome. The surfactant's kind of going to be what actually keeps the alveoli from collapsing. If the alveoli collapse, you can't get proper blood exchange from the alveoli to the blood, right? So that's kind of our landmark, that 20 to 26 week period. Okay, we've done this at length, right? Type 1 pneumocytes and type 2, those type 2s are going to be the ones that make the surfactant, that keep that the alveoli open. Now you can see here, it'll stabilize the size, keep it from collapsing, excuse me, increases compliance, meaning allow it to expand, and it'll also keep the lungs dry, right? So you don't want any sort of consolidation, such as pneumonia, right? So the primary reason you use it is to decrease surface tension. And that's what we're going to discuss in a second. This is going to be one of those words. I try not to remember words like this. It's actually abbreviated DPPT, or maybe no, it's DPPC. Sorry. Yeah. So because if you remember DPPC, then and you see this word, it kind of works out. I don't know if that works for you. It's kind of a trick way of doing it that you don't have to try to remember these crazy long words. But yeah. All right, now, this is where we talk about surfactant. Now, in principle, actually, well, yeah, I don't think my slide's coming up in a second. Okay, so in principle, this idea of surface tension is all acting towards the middle. So if we're assuming we have no surfactant here, the surface tension is going to cause a collapse of this circle, right? The surface tension is going to push and collapse the circle, because that's what the tension is on the outside. It's an inward force. Now, what you need to keep in mind is with the increased radius, you're going to get decreased pressure. It's a good concept to understand. Increased radius means decreased pressure. Now, this is why that's important. If we have an increased radius, we have decreased pressure, right? So this one has increased radius, so it has a decreased pressure compared to this one. Now, what happens if we have air in these? Well, if this has increased pressure, it's going to cause all the air to go to this circle or this alveoli, right? And so therefore, this is going to collapse. And that's the idea, is that increased radius equals decreased pressure. Now, you can see how this creates a problem, right? Because if you have a bunch of alveoli in the lungs and some are smaller than the others, all the small ones are going to collapse and all the air is going to go to the larger ones. Now, this is the concept of surface tension. So the body has to evolve a way to being able to cope with this. Now, if you were looking at this like me the first time you saw this, if I was to turn this valve, my thought would be that all the air, because there's more air over here, would go to this little small balloon. That makes sense, right? Well, that's not what happens, actually. I don't know if it's considered a paradox or whatever, but if you open this valve right here, the air from here, this purple balloon, is going to go to this orange balloon. And I think this very much illustrates, and it was like a light bulb that went off in my head to kind of explain how this idea of surface tension works. So turn the valve, this balloon or alveoli would collapse due to surface tension, okay? And that's the same idea. This has increased radius, so therefore it's decreased pressure. If you don't believe me, you could type that in and go watch it. But yeah, so that's the idea. So the body has to develop surfactant. Now, the surfactant is going to directly oppose the surface tension. Okay, so that surface tension is going to cause that's a great circle, an inward force to collapse it. What the surfactant is going to do is going to cause an outward force. Okay, so it's going to counteract that surface tension, therefore allowing the smaller alveoli to stay open. This is why if you have a premature child that's born before 20 weeks, they end up with respiratory distress syndrome because that surface tension is too much to overcome. You don't have the surfactant to push outward to keep the alveoli open. Okay, all right, now this is what makes the surfactant idea so interesting. So follow along with me here. Right, so this is area. So the alveoli is largest at this point and smallest at this point, okay? Now, so when do we need the surfactant to be most condensed? So the more condensed it is, the more active it is, right? The more able it is to surround the alveoli. Well, we need it to be most condensed and most, condensed or encompassing the alveoli when it's the smallest. Because remember, and that's 0.3. The alveoli is the smallest at 0.3. So at 0.3, there's all of the surfactant is, you could see, kind of bunched up right here, right? So it's actively pushing outward on this little alveoli, okay? And why is that important? Well, that goes back to the idea that smaller radius, right? 0.3 is the smallest radius right here, has an increased pressure. So conveniently, we have a lot of bunched up surfactant molecules to have a lot of force outward. Okay, this is an important concept you need to wrap your head around. Now, once we get to the larger, the larger point, right? 1 is the largest. Now, at this point, the surfactant's it's not super bunched up, right? So, but again, once we get to the larger alveoli, we have increased radius equals decreased pressure, right? So it's not super important that this alveoli is bunched up. Now it does play a part in you over expanding your alveoli. So it will prevent hyperinflation at this point. But the key thing to remember here is when the alveoli is at its smallest, it has the most pressure. So at the point where there's most inward pressure, you need to have the most outward pressure too. And that's why the surfactant looks like this. We did have a question like this asking us kind of where everything fits, but that should make sense. They're bunched up here because they need to fight off that pressure, okay? Hope that made sense.